ensuring a reliable and level playing field. On the next slide, I will briefly present the agenda. We are lucky to have our session hosted by the BuildUp portal. We are now in my part, the welcome by the session moderator. Then we will have a welcome from the BuildUp portal editorial team, which will be continued by a welcome and intro on the actual topic by Quentin Holtz, Director, Green and Healthy Buildings at European Copper Institute. Following that, we have three keynotes, one from DG Energy by Paul Garcia-Woody, who is a policy officer, another one by Dick Van Dyke from the EPB Center, one of our EPB experts, and the third one from Hélène Sibilo, Senior Policy Advisor at BPIE. And then we will get to the second half of our session, where we have a moderated panel discussion by our colleague Rémi Colombe at EuroAce. With the panelists, I will not read everybody, and then we will wrap things up with a set of closing remarks from Nerea at ECTP. I hereby pass the floor over to our colleagues at BuildUp portal team, and thank you again for acting as our host today.
Thank you, Andrei. Good morning and welcome all to today's webinar. I'm Arantzazu Galán, part of the editorial board of BuildUp. BuildUp is Europe's largest international portal for energy efficiency and renewable energy in buildings. It is a unique community that provides the opportunity to discuss, contribute, and collaborate with other experts in this field. BuildUp aims to bring together stakeholders working in the build-up sector to reap collective intelligence about energy reduction by encouraging knowledge exchange. Our editorial work is organized around a topic of the month, which allows us to get deeper into a specific theme. Each month, several items are produced as overview and technical articles and infographics, but not exclusively. BuildUp also offers the opportunity to host webinars on all the topics related to energy efficiency, as it is today. More recently, BuildUp has opened the opportunity to distinguished experts in the field to share their knowledge in front of our cameras in the BuildUp Expert Talks. BuildUp portal shares daily the most relevant events in the field of energy efficiency and renewable energy, but also participates actively in many European events around the year, as EPB Center and RIVA conferences, Horizon 2020, Interreg and Cost Action events, Covenant of Mayors, and much more, with the aim of further disseminating the results and helping to create high-quality media content. BuildUp content is updated daily, reaching around 120 new items each month. But BuildUp is not only us. BuildUp is a community, and we invite you to be part of it by becoming a member. You can contribute uploading your own content and promoting your own news, events, or publications. BuildUp will help you to reach a broader audience through our social media channels and newsletter. It is a pleasure to host today's webinar, already presented by Andrei. I leave now the floor to Quentin Holtz, Director of Green and Healthy Buildings in ECI, who will present and introduce the webinar. Thank you and enjoy.
Thank you, everyone, and good afternoon. Welcome to this session on behalf of all the co-organizers. So I'm Quentin Holtz, Director for Green and Healthy Buildings at the European Copper Institute. If you cannot measure it, you cannot improve it. It's a famous quote with some discussion about its author, actually, but I like to attribute it to Lord Kelvin, who at least expressed a very similar idea and made significant contribution to the laws of thermodynamics that we are also using when we do calculation of energy performance of building. In the context of the EPBD, so the Energy Performance of Buildings Directive, and building performance assessment in general, we should actually say that you can only improve the performance that you model. So if you don't model it, you cannot improve it. Indeed, the EPBD is based on a modeled performance and not on a measured performance. And a consequence of this choice is that we need to make sure that the building performance assessment method is sufficiently close to reality, is holistic, is transparent, is applied consistently, and is based on robust data. These are important aims of the CEN ISO EPBD standards that we will discuss today, and that's why our session is highly relevant. I would like to insist on the holistic aspects. So what you don't model, you cannot improve. For me, it means that the model must encompass all, or at least most, of the technical possibilities available to improve the performance. That will allow to capture all or most of the energy efficiency potential. And I will illustrate this with two possibilities that are currently not well covered. So take it as an example, there might be other, of course. The first one is related to domestic hot water. In line with the Annex 1 of the EPBD, the model is today considering the efficiency of the heat supply and the efficiency of the hot water distribution. But one aspect that is not considered is the possibility to apply heat recovery on the hot water. There are various systems on the market to allow to do this, with always the same principle as you can see on the slide, that you have a heat exchanger below a shower that will recover the heat of the water that is going to the drain. So after you shower, the heat is usually directly lost, and with a heat exchanger, you can recover the heat to preheat the cold water. A simple system can save up to 30% energy on domestic hot water for households, and domestic hot water is a quite important energy consumption point. So that's a great system, but it's difficult to sell it on the market if the energy saving is not reflected into the energy performance certificate of your building. So therefore, we need the model to include heat recovery. My second example is related to electrical installations. When you transport electricity, there are losses that can be minimized by choosing the optimal section of the conductor, but also by optimizing the installation with the location of it, the load management, control and monitoring. Today, 2% of the electricity generated in the EU is lost within the in-building electrical installations. 2%, that's quite a lot. And it is estimated that these losses could be divided by 2 with optimal dimensioning of the electrical installation. Again, improving the efficiency requires to model it. These two examples illustrate our need to have building performance assessment methods that are sufficiently close to reality, holistic, transparent, applied consistently, and based on robust data. And now I'm looking forward to our discussion on this topic. Thank you.
We pass now the floor to our guest from the European Commission, DG Energy, Paul Garcia Audi. Paul, please, the floor is yours.
Hello, good afternoon, everybody. First of all, I apologize to the organizers of this event because I had some technical issues at the very last minute, and as a result, I'm connecting via the phone. So I hope the quality of the audio is not too bad. I'll continue by thank you everybody, and especially the organizers for being here today. This is a very relevant topic for us, and it will be so for the coming months while we continue the discussions on the revision of the EPBD. So next slide, please. So on the energy performance of buildings, we, as already mentioned before, it is very, very necessary to measure the performance of a building. That's why, in fact, the energy performance, it's the first, technically it's the third article, but it's the first one that really starts getting into the substance. The first just describes what the EPBD is about, the second is definitions, the third requires member states to adopt a methodology for calculating the energy performance of a building. And this calculation methodology has to respond to a general framework that is described in Annex 1 of the original EPBD. You can see a small picture of this Annex 1, and this is everything This was the whole calculation methodology as described in the first EPBD. You will see that there are no formulas. It just indicates what elements need to be taken into considerations, and also that we need to address the fact that there are different building typologies. It was that simple in the beginning. In 2010, when we revised the EPBD, we expanded this general framework a little bit. We introduced further references to the fact that we had to account for typical conditions, because, well, as most of you will know, we design a building according to the design conditions, but we also need to make absolutely sure that the building will be able to correspond to multiple scenarios. And also in 2010, we indicated we started the mandate for 8.0, which was a mandate to ISO to start developing a set of standards on the energy performance calculation of buildings. This set of standards was designed and was made on purpose to support the application of the EPBD. In 2018, we further amended the EPBD. There wasn't very much introduced in this case. We basically introduced a common indicator, which is in primary energy kilowatt hours per square meter, and we also introduced a number of references to the standards and an obligation for member states to report. So we speak with member states with a common language. So in 2021, with the current proposal for a recast, these are the elements that we're discussing today with the member states and parliament. We also propose a number of changes on the methodology. You can see now that this is in the image. You can see some snapshots of Annex 1. We've gone from almost 1 page to 3.5 pages, with triple the amount of information on the calculation methodology. There are a number of changes that we introduce in this proposal. First of all, we'll go from monthly to hourly calculations because we feel that it's very important that these calculations are as precise as possible. We also introduce conditions for the use of measured energy. We believe that it is possible to determine the performance of a building, but through measured data. But you need to take a number of elements into consideration. So we introduce these elements, which should be developed further later on. We also introduce links to the product regulation because there is a lot of information on the performance of different products coming from eco-design and energy labeling. So we want to make sure that whatever information is available from those sources is also available for the calculation of buildings' performance. And then we also recognize the benefits of primary energies in supply because, particularly, for example, for things like district heating systems, it should be possible to clearly demonstrate the benefits of these systems. And if those benefits are demonstrated, then we should be able to use that data for the use of district heating in the calculation of energy performance. These changes respond to a number of different articles in the EPBD. In particular, they respond to the need to improve the minimum energy performance requirements for new and existing buildings. They respond to the need to have the cost-optimal methodology and how we calculate these minimum energy performance requirements. They respond to the energy performance certificate, which is how we demonstrate a lot of these elements. And it also links to the need to demonstrate that whatever we invest in buildings actually results in an increase in energy performance. Next slide, please. With regards to the EPBD revision and the focus area, just to highlight a number of elements that are very, very relevant for the calculation methodology. The energy performance certificates I've already mentioned, and very much linked to these certificates are the minimum energy performance standards. This is an obligation on the worst performing building stocks to make sure that these are renovated. They also have an effect on the building renovation passports because you need to demonstrate the increasing performance of the building. It has a very clear link to the calculation of zero emission buildings, which will be the new standard for constructions of buildings from 2030 and onwards. It has links with EPC digitalization and databases, with infrastructure for sustainable mobility, and with the deep renovation standard as well. The calculation methodology is one of the articles that really touches or has knock-on effects on pretty much everything else in the EPBD. Next slide, please. So in short, for the calculation methodology, there are a number of requirements and a number of elements that need to be taken into consideration. First of all, the calculation methodology has to be very flexible. We have 27 member states, and bear in mind that a lot of these member states have very relevant regional aspects. It's not the same to design a building for the south of Italy than to design a building for the north of Italy, let alone design a building from southern Spain to compare to, for example, northern Finland. There are also very significant differences in the way we've designed buildings over the course of the years, the way that we carry out standard calculations for the design of buildings, etc., etc. This energy performance calculation is not something that was designed in isolation. It needs to fit with a common practice into industry. Also very important to highlight, and this has already been mentioned before, the Energy Performance of Buildings Directive is based on what we call an asset calculation. This is, we calculate the energy performance of the building based on standardized conditions. The best way I found to describe this is very, very similar to what we do with cars. When you buy a car, you know that your car will consume X number of liters every 100 kilometers. And it should be fully understandable that that is a standard figure. It's a comparable figure for different types of cars. But the final result, what will actually be reflected in your pocket, the amount of fuel that you will have to put in, will largely depend on how you drive that car. It's also very important, though, that these standardized conditions reflect the typical operation of the building. And there again, we have the necessity to show the flexibility of the systems, because different buildings are used in very different conditions depending on where this building is located or who is going to use this building. Nevertheless, with all of these, with these standardized conditions that reflects typical operations, we can come down to a common indicator. For these, we use the primary energy use. This is the equivalent of the liters per 100 kilometers. Many people will say it's not a perfect indicator. I would agree. The more indicators we have, the better we can reflect the actual performance of the building. But if we have to use one single indicator, this is the best one that we could come up with. And it relies a lot on the calculation of the primary energy factors. The fact is that buildings have to rely on the grid for a lot of the energy consumption. And this grid has a number of efficiencies and inefficiencies. And depending on the type of energy supply that you use in the building, there are knock-on effects on the larger energy systems. And at the end of the day, buildings are linked to this energy grid. However, additional indicators are absolutely possible. For example, kilograms of CO2 per meter square per year, that allows us to give a very clear indication of what's the impact in terms of emission and climate change of the building. And I now come down to the last element, which is whether we use calculated or measured data. We can use both. The EPBD allows the use of both sources of information, with a caveat that if we are using measured data, we need to make absolutely sure that we can extract from these the influence of the user or the climate. If we take the measured data in a very cold year, it won't be the same as we compare it to a building, or the same building even, in a hot year. So we need to make sure that we extract these elements. Otherwise, it is really not possible to do a proper comparison. In practice, this calculation has resulted in differences in the application between member states. As I mentioned, there is a need for this flexibility. The calculation methodology is used in different stages. It's used, for example, for determining the compliance of the building at the design stage or the construction stage. It's also used for the production of energy performance certificates. And it's also used, even though that's not exactly meant to be used exactly like that, but you can use the calculation methodology and modify the standard conditions to come up with what exactly your building is going to be doing in practice. There are a number of ways in which member states have also set up these calculation methodologies. In some member states, you have one single centralized engines. In other member states, on the other side, they have certification systems. So they license pieces of software that do comply with the calculation methodology. These can link to multiple calculation software suites. And one of the challenges for the coming years is to make sure that we can link as much as possible this calculation methodology with the tools that engineers and architects use on an everyday to-day basis, because otherwise it's just introducing information in multiple pieces of software, which is not always the most practical way of doing it. Next slide, please. And this is already my last one. On the last element that I wanted to highlight is, I mentioned it briefly before, in 2010 with the EPBD, we also issued a mandate for the development of standard for the calculation of energy performance of buildings. A number of elements were very clear in the development of these standards. First of all, we needed to have this flexibility that I mentioned certain times. In order to do that, the standards have been developed in a modular approach. You can adopt all of the standards, part of them. You can pick and choose whatever it's useful for you. In terms of obligations, member states are not obliged to use the standards. There is no obligation to adopt them. However, there is an obligation to report the calculation methodologies in member states using the language of those standards, using the templates developed on those standards. These allow us to have a common understanding of what the different methodologies can do, and also it allows us to compare the different calculation methodologies. There are a number of standards that are directly identified in the EPBD, for example, all the overarching standards, but also the indoor requirements and the primary energy factors standards. In addition to setting up this set of standards, we've also supported the development of a support service. This is the EPB Center, which is one of the organizers of today's session. You can find you can find further details on how to reach them in the links indicated in the presentation. There is documentation, frequently asked questions, case studies, webinars such as this one today, explaining each and every one of the different elements. So I hope this was interesting for you today. I can only emphasize again the importance of the calculation methodology. It is really at the center of pretty much everything we do in the EPBD, and it determines a lot of the different elements that we have to work on an everyday basis. So thank you very much, and good continuation with the webinar.
Thank you very much, Pau, for making the time to join us. And as I understood from you, it's very busy times. So thank you very much for having joined us. We understand that you need to leave already because you have other meetings that you need to join. But we look forward to keeping an open contact. Thank you again. Now it's time for my colleague from the EPB Center, Dick van Dijk, to take the floor. Please, Dick, the floor is yours.
Okay, thank you, Andrei. So my name is Dick van Dijk. I'm EPB Center expert and also one of the initiators. And I'm also chair of the ISO Joint Advisory Group on the set of EPB standards, so the EN ISO 52000 family of standards. And the title of my presentation is the CEN ISO EPB standards and the EPBD's implementation. So we're speaking about a set of harmonized European and global EPB standards. This is a Europe-wide and to a great extent also globally converged calculation methodology to assess the overall energy performance of buildings. As Pau already mentioned, it's for the EPA certificates for benchmarking and checking compliance with minimum energy performance requirements. And it should also be stressed that it is for new and existing residential and non-residential buildings alike. Most of these standards were published in 2017 as a result of the mandate mentioned by Pau. The current status is that they are being implemented in a growing number of countries. The set is also being expanded and reviewed. So the set follows a holistic systemic approach, starting from the product and component data via the energy needs and the system performance to the overall building energy performance. And as also already mentioned by Pau, the modular approach has been adopted which means that you have a subdivision into overarching standards, standards on heating and cooling system, domestic hot water, ventilation, lighting, building automation and control, and on building and building components. And here you see the numbers of sub-modules in these sets, which indeed makes it quite flexible to adopt the whole set or to start with a number of the standards, and where needed to have hopefully temporarily national standards to fill in some gaps if there are. So why is it important to have and to use this set? If you look at the energy performance calculation methodology, it's not only the calculation method itself, it also concerns common definitions. So for instance, the definition on the primary energy, definition on and specification of the floor area. If you speak about square meters, kilowatt hour per square meter, it's very vital that you know which square meters are you talking about. And also the assumed outdoor and indoor conditions, so the climatic data, of course, and the temperature settings, ventilation requirements, lighting requirements, depending on the function of the building. And that altogether gives you an energy performance value in, well, kilowatt hours per square meter, if we look at the primary energy. But then the question is, yeah, what does it mean? It doesn't mean actually anything if you have just a value and you have no benchmarks to compare with. If you have a meter, you have to know what is the 0, what is the 100 centimeters, and then then you have a benchmark. So you need benchmarks, reference values to give a meaning to the energy performance value, and only then you have a metric. So the set of EPB standards is a common energy performance assessment methodology consisting of definitions, actual calculation methods, sets of assumed outdoor and indoor conditions, and energy performance indicators. And if one of these is different, you have a different methodology, you have different output and a different meaning. Yeah, so then is it a one-size-fits-all? No, already stressed by Pau, you need to be flexible to allow national choices. For instance, for the climatic conditions, also for primary energy factor values, which reflect the national infrastructure, for instance. But yeah, if you want to have a common metric and comparison between countries, you should aim to have the possibility to converge to a common reference. Yeah, so the time today is very short. There's a lot more to say about it, but luckily we have this website of the EPB Center, as Pau mentioned, where you can find a lot of information. Also, you can ask questions via the EPB Center website. So yes, we have a large amount of information on the set of standards and individual standards, frequently asked questions, webinar recordings, short videos, recently updated tools. Very new is a number of detailed case studies on individual standards and on the overall energy performance calculation, and this is still growing. Yeah, I could also introduce a number of key EPB standards, but there's no time actually to go into the depth to this slide. So what I will do, I will upload this slide with dynamic links from each of these blocks to more information on all of these key standards. I'll put it on the website and you can have a look at it. Just one thing I want to highlight is that you see in many places EN ISO 52000 appearing, so 52000 to 52120 and more. So these are the EN ISO 52000 family of standards, and more standards. When they are upgraded from CEN standards to the global level, they become part of this family of standards. Now something about the future development of the set of EPB standards. Actually, as we speak, there is a systematic review going on of all the EPB standards that were published 5 years ago in both CEN and ISO. And for this unique occasion, a team of CEN and ISO experts prepared and distributed an informal guidance document which contains extensive background information, but also food for thought and questions for all the relevant mirror committees of the national CEN and ISO member bodies to provide feedback on individual standards and on the whole set. And of course, this kind of information and these questions are also interested for other stakeholders. So this information can also be downloaded from the EPB Center website. And if you have, as a stakeholder, interest in filling in the questions, you can also submit the response to the EPB Center via the website or directly to experts if you have their email addresses. Now, if you ask what do you see as a priority for the future, then actually maybe little teasing what Pau said, I would like to see less options for national choice to establish an increased convergence. And also digitalization of the standards. There's an ISO Smart program aiming for more digitized standards in the future. The program is not very clear yet, so we hope to have a fruitful discussion and pilot projects in this program to help the digitalization of standards. And that brings me to the next one, is to prepare an open source core framework software tool, which would remove one of the major barriers for implementing and using the EPB standards. The next one is to bring more EPB CEN standards to global ISO level, because it's not the idea of a Europe in splendid isolation. All the problems are worldwide the same. Include new demands and features from the EPBD recast, of course. Include new technologies, was already mentioned by Quentin. So, for instance, batteries should be one of those which are still now missing in the list. Then it brings me to the importance of a transparent and meaningful energy performance indicators, which is linked to the Energy Performance of Buildings Directive. So first, look at the definition of total primary energy performance. This is simply the sum of non-renewable and renewable energy performance, and therefore it's called total, and should not be confused with the overall primary energy performance, which is the energy performance of the whole building. In any case, if you speak about primary energy performance, it's not enough. You have to specify whether you speak about the total or the non-renewable or the renewable energy performance. Otherwise, we are not clear, and you're speaking about different things. Another aspect which is important when it comes to calculations and definitions, in particular relevant when it comes to renewable energy produced and used on site, like PV panels, is the concept of net annual energy performance, in which case the energy balance is averaged over a longer period, in this case of a year. And so the need for electricity from the grid during the evening or during wintertime is then compensated in the calculation by the surplus of PV during the day or during summer. Well, this might have been a fair approach for the nearly zero energy buildings, but when we want to come to truly zero emission buildings, then this is no longer the case. Summer day surplus does not cover the winter or night. Summer or day surplus does not cover the winter or the night shortage. It's only compensated in the calculation. It disguises that there's actually non-renewable energy used. So if this is the route towards zero emission buildings, it's a fake zero emission building. It's not covering, but actually it's covering up the use of non-renewable energy. And it also, and maybe as important, it hinders the optimization of the energy balance between the building and the grid. For instance, it hinders the appreciation of the smart use of equipment and batteries. So instead of that, we should aim for the annual primary energy based on an hourly energy balance calculation. And I'm happy to see that this is also the route that is followed in the EPBD proposal by the European Commission. Of course, I can show many illustrations of this, of it, and in the case studies on the EPB Center website, you find those. So there's an absolute need for hourly calculation steps. Here you see an example of a surplus of own-produced PV electricity during the day and a shortage during the night, and you would cover up the need for electricity from the grid if you take a daily or monthly average. And by the way, these hourly calculation steps are also very important to get a clear indication on the thermal comfort or indoor environment quality. Another aspect is the question, what indicator is needed to more or less assure a high energy efficient building, to have a threshold to ensure that the building itself is highly energy efficient. It's not the total primary energy, because this includes renewable energy that is used to achieve a high efficiency building. And if you have a threshold on the total primary energy of the building, then you punish people who have a solar boiler installed in their building. So a useful indicator would be the amount of energy that has to be delivered to the building site from nearby or distant, may at the moment still be partly non-renewable or fully renewable. And to be clear, this is not intended as a replacement, but as an addition to the overall non-renewable energy performance. So in terms of the EN ISO 52000 assessment boundaries, where you have on-site, nearby and distant, there we normally say, well, the renewable energy produced on site, we see that as energy delivered to the site, to have a clear recognition of this. But for the purpose of finding the residual energy still required and assessing the high energy efficiency of the building itself, we should draw the boundary here, where the renewable energy produced on site is included in the energy balance. So it's not punished. It's seen as part of the energy measures taken on site. And the positive by-effect is that there's no need for difficult discussions on where and how to assess the amount of renewable energy produced and used on site. And I'm not going into the details, but I'm sure that several of you are aware of this problem with the definition. So here in another diagram, the residual amount of energy to be delivered to the building, actually it looks quite similar to what you would find on the meter of your building site. So all the renewable energy produced and used on site is then implicitly taken into account. You do not punish it, so you do not punish, for instance, the solar boiler on site. On the other hand, what has to be delivered from nearby or from the grid, that could include renewable energy, and in this way, by drawing the boundary here for this residual amount of energy to be delivered to the building, you take not for granted that this includes a requirement to have renewable energy from nearby or from the grid, because you cannot assume that that's unlimitedly freely available for all. So that brings you to these successive assessment steps. So on the building side, you have the performance of the building envelope as a metric. You have the performance of the technical building systems. We know from the EPBD proposal, we go for a zero carbon from fossil energy at the building, into the building. We have the performance regarding thermal comfort, indoor environment quality, and then you have this residual energy still to be delivered to the building site, which gives you the indication of the building energy efficiency. And then the next is, well, how to cover this residual energy, which is still to be delivered to the building site. Well, that's by nearby and distant sources. At this moment, these sources are not 100% renewable in most cases. So this calls for the national policy for trajectories for decreasing the non-renewable share in the nearby, so from district level and from the grid to in a couple of years' time to come to really zero emission buildings. And yeah, that brings me to the conclusions, but for the sake of time, I'll skip the conclusions because it's just repeating, briefly summarizing what I said before. And just pointing again to the information you can find at the EPB Center website, where you also can find this guidance document for feedback on the set of EPB standards, and about this metric for the efficiency at the boundary of the building site. You can find more information on that and more details in the RIVA journal paper from the most recent RIVA journal from myself and Jarek Konitsky. And if you have any questions, you can find the contact button at the EPB Center website, and we'll try to answer your questions. Thank you very much for your attention.
Thank you, Dick, very much. This was a quite comprehensive presentation covering very well the topic at hand. We pass now the floor to Helen Sibilo. Welcome, Helen, and she will be going into a complementing facet of building performance assessment, and that is of cost optimality. Please, Helen, the floor is yours.
Thank you, Andrei, and good afternoon, everyone. It is my pleasure to participate to this session. I am working for BPIE, the Buildings Performance Institute Europe. For those who don't know us, we are a non-profit think tank based in both Brussels and Berlin, and we're working since 2010 to provide independent research and policy advice on all matters related to building regulation, from design to implementation, with a view to help to achieve climate neutrality in the building sector by 2050. Today, I will be talking about the topic of cost optimality in the framework of the EPBD revision. And I should mention that this presentation is based on an earlier work that we carried on with Technical University Vienna for the purpose of the ECTP summer study. And this presentation builds on that earlier work. So today I will talk about cost optimality. Why is it important? Outline the current limitations, but also think about the key quality principle that we should keep in mind if we want to improve it in the future, and what are possible ways that we have now at our disposal in the EPBD revision. So first, why is cost optimality important? It has been mentioned, introduced in the EPBD in 2010 and supplemented by a delegated regulation in 2012, but not touched in the last revision in 2018. Cost optimality is a very technical topic. It might seem very difficult to enter into this topic, but it has very big impacts on the ground in terms of energy performance of buildings, and also it carries with it high political assumptions and implications. So how does it work? Basically, cost optimality drives or helps to set the minimum energy performance requirements, as it was explained by Pau and Dick, for buildings undergoing major renovation and also for new buildings. And basically it helped at the start to push energy performance from the bottom. And basically this is the kind of graphic representation that you can have on when you are calculating the cost optimal level to set your minimum energy performance requirements. Now, if we put that into perspective with what we want to achieve now and what we must deliver in the future, in terms of our EU energy and climate goals. That means the 2030 climate target, and for the building sector, a zero-emission building stock by 2050, as well as transforming existing buildings into ZEBs. We might see that indeed we have a gap between what we have now and our future goals. So what is this gap and why is it important? It's important because if you look at what is actually happening on the ground, we have noticed that the building stock is actually not on track with full decarbonization or climate neutrality by 2050. And this has recently been shown by BPIE in our Buildings Climate Tracker, which you can consult at the link that I've put on the slides. And basically what you see on the slide is the, let's say, latest progress in the last 4 to 5 years in the dark blue line compared to what we should be doing in the dotted gray line to reach climate neutrality by 2050. And you can see there is a growing gap that needs to be closed, and that can be closed through stronger and accelerated policy action. So I think this is a strong argument in favor of opening the discussions on the EPBD methodological framework on how to set energy performance requirements, and also question whether the framework that we have at the moment is still fit for purpose, considering where we need to go and where we are right now. So in terms of the cost optimality limitations that we have at the moment, I think the big message is the misalignment with our climate targets for 2030 and 2050. If we look more into the details, which limitations exactly can we talk about? And these are put as questions because it's more about raising questions and questioning what we have at the moment rather than giving you now all the solutions and all the answers. But I think we can question whether the technological or the assumptions used are outdated or not. We can, I think, also question whether the carbon emissions costs used are, now we can see much below the current values. So I think we can also question the ones that are in the delegated regulation and in the methodology. Since the current recent rise of energy prices, we have some calculation results which are not valid anymore, especially the preference, for example, given to fossil fuel boilers. Also, the sensitivity analysis, which would be done by member states, are not actually reflecting possible price shocks in the range that we have seen now. Most member states, they foresee price shocks around 10 to 30% changes, sometimes 50% for gas prices, but not more. And then the bigger question, I think the most important one, is to what extent externalities and wider benefits of building renovation are actually not considered in the cost optimal methodology. I've listed a few of these benefits here. What we have seen in the member states, how member states are using it, they're rarely discussed and even less so monetized and quantified. So basically what we have is parameters that are to some extent determined by member states. The flexibility is actually granted by the EU level methodology, but all this has an impact on the outcome of the calculation. And the consequence is a distorted picture of costs and benefits of building renovation, which of course impacts the level and the ambition at which you set your energy performance requirements. The main message from myself here is that we can question this because costs are, as we see, as uncertain as benefits, but they're still given the focus and the priority in the calculation, while benefits are completely disregarded. So there is an unequal treatment between economic and social aspects in the calculations. So in terms of how we can improve the methodology, and based on the limitations I've just mentioned before, I think these are some of the key quality principles we should look into, and more technical work is of course needed to see how to operationalize that into a new methodology. But first, ensuring multiple benefits are expressed in economic terms and considered. Also that costs of inaction are taken into account. That would rebalance the methodology between costs and benefits. Also, how to make sure that we update the guidance regularly on assumptions linked to technological developments or cost of carbon price. Another important thing to look into the future is also how we can blend mitigation and adaptation measures. When we set building requirements, how do we make sure that when a measure is both helpful for mitigating climate change and adapting to climate change, how do we consider that as a benefit, and how do we factor that into the calculation? And then considering also the appropriateness of the frequency of the update, how frequently do we have to update the methodology, update the input data, update the assumptions, and then finally, to what level of the deviation can we allow member states to go when they set their minimum energy performance requirements. Taking a step back from all these details, I think the key quality principles that we have to keep in mind when looking at the cost optimality methodology and EPBD revision is really now we have a partial view. It seems like we only have one eye open, and what we need to do is to move to something which is a bit more complete and also a longer term view. And this a more fundamental change in the cost optimal methodology, I think, can really be questioned. And maybe a shift in perspective is needed to trigger bigger impacts than just quick fixes, quick technical fixes. And overall, I think the message should be that what we do now is more or less business as usual, or we have a methodology that leads to incremental improvements. The only problem is that we don't have the time anymore for incremental improvements. And we really need to see climate neutrality, energy efficiency first as another guiding principle for optimality, and not only looking at costs. And how to say, in an optimal way, building requirements should be based on both what can be done, correcting the spectrum of cost and benefits, but also the economically feasible should be in line with what we should be delivering to achieve our longer term goals. And to finish, I would like to point out to the fact that we have now an open opportunity at the policy level, because the EPBD is currently open, as Pau was mentioning at the start, and the current revision with the proposal from the Commission includes some policy placeholders for future technical improvements, with the Commission having said that they want to revise and adopt a new delegated act by 2026, and member states to report on the new methodology by 2028. So I think we can still consider that cost optimality, even though it has a lot of flaws, it's still needed as a safety net. It can be improved, and we now have with the EPBD revision a really good opportunity to do so. So I think we can really use that revision as a way to propel positive change and really to make an impact before 2030, because that is really needed if we want to achieve our longer term targets. This is my last message, and I pass over the floor back to the moderator. Thank you very much.
Thank you very much, Helen. This has been very insightful. It is now time to go to the more interactive part of our session. We will not be having any slides from the panelists and the moderator of the panel discussion. It's just some visual supporting slides that you will be seeing on screen. And it's my great pleasure to also welcome Rémi Colombet from EuroAce, who has taken the role of moderator for the panel discussion that's coming up. I just wanted to highlight, Rémi, that if as needed, both Dick and Helen are still with us. So if you need to rely on them together with the panelists, I'm sure they would be glad to support. So the floor is yours, Rémi, and you will be introducing also our guest panelists. Thank you very much.
Great. Good afternoon, everyone. Thank you very much. My name is Rémi Colombet. I am Senior EU Affairs Officer at EuroAce, the Association for Energy Efficiency in Buildings. Well, buildings are one of the largest sources of energy consumption in Europe. They account for 40% of our energy consumption and 36% of our greenhouse gas emissions. So boosting their efficiency would clearly have great benefits in terms of climate, but also tackling energy poverty and currently energy prices and increase our energy independence. Energy performance of building standards enable the calculation and inspection of the overall performance, as we heard today, and they're essential tools to help us achieve our efficiency objectives. So consistency, transparency, and usability are essential qualities for the standards to create a really level playing field. Just before starting the discussion, I'd like to remind everyone to ask their questions in the chat, and I'll make sure to channel them to the speakers. We're really lucky today to have an excellent panel to discuss the EPB standards with Quentin Holtz, Director for Green and Healthy Buildings at the European Copper Institute, Henk Kranenberg, Senior Manager at Dijking, representing EP, Alain Zarly, Secretary General of ECTP, and Gilles Cordiot from Schneider Electric, representing EU BAC and EUACE. So maybe just as a round of introduction, it'd be good to hear from each of you why EPB standards matter for, in your perspective, for your organization. Maybe starting with Quentin.
Yeah, good afternoon again. I initiated already this into my introduction, so I can be very brief. But for us, copper contributes to many solutions in buildings to improve the efficiency, to produce renewable, etc. And what we want is to make sure that they can really bring all their benefits. And for this, as we discussed already, we need the models, so the assessment method to cover all these aspects. And so we see some elements where there are still some gaps. This can be improved, as I gave some examples before. So on the topic of heat recovery on domestic hot water or electrical installations, where we can still improve efficiency. Now we are in a time where we need every savings, every opportunity to contribute. And so that's where we need to have it down. As it was explained, the importance of the standard and the model is very high, because that's the basis for the regulation, that's the basis for improvement. And we really welcome to have this calculation model and to have this continuous improvement. And it's also important that they are widely applied.
Great. Henk?
Yeah, thank you very much, Remy. My name is Henk Kranenberg from Dijking. I'm representing EP here. And it's rather obvious. In the built environment, up to 50% over the previous years, energy was consumed for heating and cooling. So it's very obvious if we want to improve the energy efficiency in the built environment, this is an area to have a focus on. But just a focus is not enough, because if you also look to what happened in the past and still today, then I think one of the main challenges we face is the mindset of the people who have to work with it and to understand how the buildings of the future will have to look like. And in order to give that really hands and feet, as also was explained in the previous presentations, you need very clear, non-ambiguous calculation methods on that. But not only calculation methods, because you can calculate whatever you want, but it should also be based on factual data. And already Paul addressed it by utilizing eco-design data, test data from product regulation. You have already the best available information to make this kind of building calculations. And I can give just a reference to the heat pump standard, which was also mentioned in the presentation of Dick van Dijk. This is a typical standard where in the energy performance of a heat pump, at least one of the paths, the eco-design data are used. There's still also another calculation which is more historical, how it was done in the past. But that was too general. In fact, we have to look into the details, how a product is performing. Is it full load? Is it part load? So really in its operation, when it's installed in a building, to see what the most likely energy efficiency is of the product. So in that sense, EPE is fully supporting, and this whole development is fully supporting the EPBD recast. That also the reference to the eco-design is made. That it's and that now it's pointed out to work based on hourly calculations. So we are applauding for that. Thank you.
Thanks a lot. Next, I'm calling Alain.
Yes, good afternoon to you all. So yes, I'm going to quickly introduce the view of the European Construction Technology Platform on those specific aspects of energy performance of buildings and the related standards. Just as a reminder that ECTP is an industry-led leading membership organization which promotes and influences the future of the built environment in Europe and beyond, in particular in developing and implementing new research, development, innovation strategies to improve overall the competitiveness of the built environment market, but also meet societal needs and take up environmental challenges through an innovative built environment. And in that context, I would say that ECTP by itself is not, I would say, directly participating to EPBD standards or standardization work, but of course largely leveraging on the existing standards, including of course the development of EPB standards, and trying of course to see how new research and technological development can demonstrate and improve of course the calculation method, and how, of course, this in turn can influence the evolution of those standards. Under FP7 and Horizon 2020, over 10 years, I would say that energy performance of buildings was indeed supported by the Energy Efficient Buildings PPP, which succeeded in advancing the TRL of quite a number of energy efficient and low carbon solutions for the building sector, and some of them, of course, having been mentioned by Dick in his presentation. We had, of course, a clear focus on the development of components, materials, and technologies that should, of course, serve the improvement of the energy efficiency of our buildings. And we also concentrate on the development of new ICT and software technologies that will be helpful in the way to demonstrate, indeed, that the future buildings or the renovated buildings that we're going to use in the future are going to really tackle and fit with the EPB standards that we are developing. So that's something which is very, very important. And we indeed have a clear look on, in particular, the revision of the energy performance of building directives to align its rule with European Green Deal and the renovation wave on our side. In particular in the Build for People partnership, which is a follow-up of the EEB-PPP. And around this concept of zero emission building that is defined in one way, in some way, as a building with very high energy performance, but that we will have, of course, to demonstrate to which extent it's going to be a reality. So very well, indeed, well, we work and we have already developed quite a set of research and innovation streams around aspects of the consideration of near zero buildings, but also their incorporation into districts, into integrated design and performance strategy, into also life cycle performance approaches. But we are also considering how materials are going to play a key role in the future, because there are deep changes in the way materials are produced, which are needed to align the energy performance requirements of the EU building stock to the longer term climate neutrality goal. And also, of course, what is very last not best least, of course, all the work around ICT and software too, in order to provide compliant input data, for instance, used for further issue an energy performance certificate. We are in particular having quite a lot of work currently and a lot of development around the SRI, which is part indeed of the revision of the EPBD, which is common EU methodology, which try to rate the smart readiness of buildings or buildings unit in their capability to perform optimization of the energy efficiency, adapt their operation to the needs of the occupant, and adapt to signals from the grid as well. So we try to have a comprehensive view around many different standards, but of course, EPBD standards are instrumental in the future development and the integration of our net zero buildings in our district in the future. And I stop here for the moment.
Thank you very much. Jules?
So thank you very much, Remy, and thanks again for the opportunity for EPB and Build Up, for setting up this very insightful meeting. I think I will go along, with what just Alain said. So I'm Jules Cordier with Schneider Electric, and today representing EUBAC, which is the European Association for Building Automation Control, and EUACE, the European Alliance to Save Energy. So two of the leading voice for energy efficiency and especially energy renovation of buildings. And as you can imagine, particularly active today as the EPBD is currently being revised at both the Council and the Parliament. I think I will not, remind, the importance of addressing buildings renovations. I think Henk, Quentin, and Alain mentioned, the big numbers we know about buildings, and which are particularly more important when we consider the energy crisis and how business and citizens are being impacted by the energy prices. Before we go, on the discussions, just to mention an important element, and actually two, when it comes, to addressing, an holistic performance approach to building renovations, and how we can further incentivize this performance assessment. One of the very important point was mentioned by Laila is how we incentivize and we better reflect the role of digital in the performance model and in the measuring process. One of the key aspects, to spur building renovations, and we know how it's difficult, to accelerate the energy renovation rates. So not only the renovation of building, but especially the energy renovation, because way too much of renovation does not address the energy part. And second, it does not lead, to sufficient energy efficiency improvement. Is that we really need, to send the right market signals to the investors, to the building owners and tenants, to invest in renovations. And the 2018 recast of the EPBD already, put kind of the basis, for that, and which was the smart readiness indicator. So, putting, kind of in place a framework to boost investors to invest into buildings renovations. There are many certifications already in place, BREEAM, LEED, which are already, kind of super well used by, big commercial and industrial buildings. But what is very interesting with this SRI is that it's a U-print framework, which can be first implemented for the large non-residential buildings and progressively extended to a larger scope of the building stock. But just to again highlight the fact that we have already kind of the right framework to boost, incentivize, show what can be the potential of the SRI to assess, measure performance on the vast number of aspects, because again the buildings renovations cannot be only about energy performance. It's about holistic approach to decarbonizations, considering flexibility, considering comfort, considering distributed energy resources such as solar panels and EV chargings. And that's where the SRI is the most interesting. And the second part of that on the SRI and why it can be integrated into the EPB standards is because it's already using a large number of standards which are already part of the EPB standards. That's the basis of the SRI right now. It's performance approach, but based on functionality measures by standards, which again, for a large part of them, are already part of the EPB standards.
Thanks a lot. So a lot of really good elements and food for thought there. I'll come back quickly to something that Quentin mentioned. We see now in the current negotiations on the EPBD that electrical installations might become recognized as technical building systems. What would this mean when it comes to EPB standards?
So first of all, I really welcome this idea that electrical installation are a technical building system. They are very essential. I call it the backbone of zero emission buildings, because we are going towards electrification. So we need the electrical installation to be fit for purpose and also to be efficient. So the difficulty we have when I think about EPB standards is that the language that we are using as a mechanical engineer, like I am, when we speak about building physics, is not the same as the language that electrical engineers are speaking when they design electrical installations. But basically, you could do exactly the same to calculate the losses of the electrical installation and try to reduce it. That's something that could be perfectly integrated into the standards, to my point of view. But you could also keep it as a separate point that you
You're cutting off.
optimize the electrical installation using the language of electrical engineers, which might be asking the voltage what electrical engineers use to characterize the efficiency of the installation in some way. They don't think about efficiency, they think about voltage drop, but that would also work. So I see the efficiency of the electrical installation as something that need to be considered, but that could be done separately than the elements currently covered into the EPBD standards, because it's a separate building system where there is the interaction with the more heating aspects is very reduced.
Okay, thanks a lot. Next question will be for a bit for everyone, and it concerns the flexibility of the standards. So it'd be, what are the main innovation pathways for energy efficiency in building that we see coming in the future, and how do we make sure that the EPB standards are flexible enough to encourage and adapt to innovation?
Remy, may I take the lead in this one? Because what I clearly see, I also hear the signals on innovations, but frankly speaking, a lot of today's available technology and innovation that are already placed in the market are not even fully utilized, far from being properly calculated within the energy performance calculations. So there is so much to gain already at this point of view. And looking at the standardization process, we also know this will run behind on technologies that will appear in the market. But I think even today, the technologies already offer sufficient flexibility also within these standards to assess and to include. But it's a very vital point that already at this point of time, with all the innovations that have been placed in the market already and that are so poorly assessed, that we make a leap ahead over there. And I think that is a first priority. Not willing to ignore any innovation for future. Innovation is also very important. And I could name a number of things that will for sure come up. But I think it's not relevant at this point of time. Let's do what we can do already at this point of time. Not only hide behind the future. No, let's pick it up and have already a very clear assessment on energy performance today. Like for example with storage, it was already indicated, the hourly calculations. If you do not have a properly hourly calculation, forget about giving a proper value to storage and how to utilize that. For example, then also electricity storage or heat storage. So there is already so much available where today experts in the market who have to calculate on the building design cannot give any proper remuneration on that because they don't know how to calculate, or they are not using the right standards for that. So there's still so much to do, and I would really appreciate a lot if we really join forces and take care that what we have already be properly implemented. That's the first step. Thank you.
Anyone else want to comment on this one?
If I may complement, I fully subscribe to what has been said. For this, I think it's really good that you have European standards, because one difficulty that there is today, if an innovation is coming on the market, and as mentioned, there are already many things available that actually are not well recognized into the national calculation methods. It's very difficult if the industry has to come to every member state to ask their national method to acknowledge the benefit of this solution. But that's what is happening actually now, because that's maybe where they have the easiest access. So we need to have these EU standards. We need to have revision processes as it is coming now. But I would also encourage maybe the EU Commission to think about how to support these improvements every time it's required, and so how to give access to all the industry supplying new solutions to give input and to say, hey, I have something contributing that's validated by many data, but in the calculation methods, it's not acknowledged, so we need to revise this, and I need to get support to go through the whole process, because we know standardization is quite a complex process, and we need to facilitate the access to it.
Yeah, I think this is a really good point, and the industry is always very happy to cooperate in these processes.
Yes, I think in addition to that, because it's also pointing to the Commission again, but let's not forget the EPBD directive has to be implemented by each of the member states. And at an international level, national experts were also then working on the national calculation method, because we see that European standards are hardly adopted. They have to make this translation. And there I still, day by day, I see hesitance, because they are used to work in an old methodology, not used to the new way of working. And how are we going to get by 2030 zero emission buildings if these standards of today are not even implemented? And if the next revision round will be in 5 years' time? So this will really jeopardize the whole process if we don't accelerate on this point and put more pressure and perhaps even enforce it to make it happen. Otherwise, it's nice to talk about 2030, 2050, but we mainly talk about a dream.
Remy,
yeah.
Maybe very quickly to jump into this last comment from Henk, on which I fully agree upon. Also from an industry point of view, we know that, well, and relating to digital solutions in that case, they are instrumental to ensure in the future that the real long-term performance of our built environment will be in line, in particular, for instance, with the design ones. And we need, in that case, of course, to rely on certification, standardization, and certification systems as well. So what is interesting is that, for instance, in the EPBD, it's now going to involve a smartness upgrade of existing buildings, as reflected in the smart readiness indicator, to optimize the building performance during subsequent operation and maintenance stages. But what is also important is that these define a framework in which indeed the industry can develop software that are going indeed to answer to those key aspects of demonstrating indeed the performance of our building. This requires indeed data, and we have to validate indeed the data, but we have also to ensure that the software are able to understand those data, and that the software are going to operate in some way some different functions which corresponds indeed to the calculation methods provided by standards just like EPB. So this provides also a framework from my point of view to the industry in order to improve their software that will in turn in some way help, of course, us to demonstrate that our buildings are moving toward the targets and the impact that we are expecting.
I think it's a very good point to point out on the software, as this is, I think it was already indicated by Dick van Dijk to work on this kernel software to make it available for all the member states and to bring this package of all these standards together. And I think this is very well spent money by the EU Commission. If you make a next step, work on this software. Keep it stupid simple for the people to make use out of it. Still make it available to the local software developers. They can put their umbrella around it, but the software, the engine itself, that is what should become available as quick as possible. I fully agree.
Maybe a question to turn back on what we heard just before on cost optimality calculations. We heard that they're not in line with European objectives at the moment, and I was wondering whether this is a view shared by TBS suppliers, and whether you think policymakers should go beyond cost optimality at this stage.
I hear no answers, but anyhow, to give a quick reaction on that, just to something to think about. If people invest in a kitchen or a bathroom, cost optimality is not an issue. If we care about our climate, our environment, is cost optimality an issue? Should we compare it more with our bathroom and the kitchen? I'd like to leave it to that question.
Maybe also, if you think about cost optimality, what was cost optimal 1 year ago, or maybe something that was not cost optimal 1 year ago will very likely be cost optimal today with the change in energy prices. So I understand where it's coming from. I understand you need to look at the cost and benefits. But now we have clear objectives that are we need to be zero emission at the end. And the question is how to go there in a cost optimal way. It's not to see which cost optimal small improvement you can do. So we need to help every household now to go to zero emission buildings, to go to clean heating, to get rid of fossil, to get rid of these high energy costs. And that's the aim. And then we also have the question of what is cost optimal for one individual and what is actually cost optimal for society, for the energy system. And so the more we can do in buildings to reduce the energy demand there, the more we will also reduce the cost of energy for everyone. So there are some places where we need energy. There are some places where we can just manage to come to zero. That's in buildings. And so that's now far better to invest into efficiency in buildings than to invest in paying energy bills of people that cannot afford to pay their bill anymore. Of course, we need to support them, but the efficiency of the building should be a priority. And you cannot use cost optimality as a reason not to do the things. That's what is important.
Yeah, thanks for this reaction. I'm a bit conscious of the time, and I'd like to leave some time for the conclusion. So I'll go with one last question, and maybe starting with Jules. If you had one thing to ask policymakers currently working on the EPBD revision, what would it be?
I think that beyond all the elements which have been mentioned on cost optimality, which indeed are clear, that we need to add more elements, to this specific article. There are maybe, two very important points. I think that the first one is again, to set up, the right market signals to spur buildings renovations, and making, the SRI mandatory for the largest non-residential buildings will be a first step. So first, for the buildings which have to be equipped with building automation and control, for instance, because again, for instance, from BACs, those are standards which are already referenced in the EPB standards, in the cost optimality level, and the Annex 1 of the energy performance of buildings, Annex 1 and 5. So, they are already the reference standards for those solutions. So we'll recommend, to have the SRI mandatory for those largest buildings, and to extend it, to buildings with 70 kilowatts by 2019, which is the recommendation of the Commission, and is being supported, by most of the European Parliament rapporteur and shadow rapporteur. And maybe, the second element is more related, to how we enforce and we make sure, that those standards are being respected, and therefore the requirements for the EPBD are being respected. And we've seen, that in many countries they are already late, in implementing many aspects of the EPBD. That includes, for instance, on the building automation controls, and we've seen many countries, which are not reporting on how it's being implemented. And therefore, the aspect, to link the EPB standards, the measurement and holistic, transparent process is on market surveillance. So to make sure that the market surveillance authorities have the right resources and right mechanism in place to make sure that the standards and the requirements are being implemented.
Sorry for that. So Hélène, you wanted to jump in?
Yes, I would like to also make a contribution here in terms of policymakers, because this is what I'm focusing on at BPIE is giving policy advice. And here it's difficult to pick one thing, but if I could summarize it, I would say that it's more being in a certain attitude. And I would really like policymakers from all fronts, Council and Parliament, and also the Commission, to whatever policy measures they're designing, whether it's very technical, whether it's a more political measure, that they always keep in mind the climate neutrality objective, but also a social fairness perspective, because we need a renovation wave to deliver, and also to deliver to the most vulnerable in our society, and making sure that with all what is going on, we need to to develop measures that are also fitting coherently with one another. That being within the EPBD, there are so many things being open at the moment, but also with other files of the Fit for 55 package. I think it's a massive challenge for the human brain, but I think we have a lot of bright people around the table in institutions and around to make it work. So that would be my message to everyone working on EPBD.
Quentin, maybe?
Yes, in short, I would say don't push it back. I think the best time to invest into efficiency of buildings was 10 years ago. The second best time is today. Let's not wait 10 more years. We really need to deliver. And that's why I'm a bit concerned when I see discussions by some policymakers that just try to say, okay, good idea, but let's push it back for a few years, whatever. And if we know what to do, let's do it now. Of course, it will be a challenge to deliver, but we really need to put the ambition right.
I can't agree more. Henk?
Yes, let's switch on again. So I think it's I fully agree with Quentin. We have to act now already. Many things are possible. Technologies are available, and these are technologies that are very sustainable. What is already available, and of course, more new clever ideas will come up in the future, but they will come by that time. We should not wait for that. We should try to maximize already the energy performance at this point of time, and this is also requiring a good combination from the envelope side together with the technical building systems. So we should not think too much out of silos. Okay, let's make just the envelope as tight as possible. And I see sometimes there's also some question, I think, in the meantime on passive housing. Will we go over there? I think that is if you try to apply principles in this process, this will be an endless road. Let's approach it from this holistic point of view, see how we can collaborate from the envelope side, from the technical building system side, and really deliver on low energy consuming buildings in the European society. That's how we can make steps ahead. Thank you.
Thanks a lot. And maybe Alain for the final closing words.
I'm afraid that Alain had to leave us due to some flight connections that were changed in the meantime. So it will be only Nerea giving the closing remarks from ECTP. So I take the opportunity now to thank you, Remy, for managing very well this panel discussion. It's those type of discussions, and a big thank you also to the panelists. Is those type of discussions that I wouldn't want to stop at all, but we have a timeline. We are still a few minutes over, so I give the floor to you, Nerea, for the closing remarks. Thank you.
Thank you very much. I'm Nerea, also from ECTP, and I would like to start these closing remarks with some words that Quentin Holtz said at the beginning of this session. What you cannot model, you cannot improve. And this has been the guiding thread through all the session. We have had the opportunity to listen to experts from different fields debate about the importance of choices made in the building performance assessment methods and high impact in decarbonizing the European building stock. And this is why it is fundamental to develop a transparent and holistic approach based on 4 key aspects that have been all mentioned by the speakers. First, renovation. We need to contribute to the energy performance standards and implement some meaningful EP indicators. Then the decarbonization. In order to achieve this challenge of a complete decarbonization by 2050, we need to tackle some growing gaps that need to be closed through policy action. And then the modernization and the integration of different systems and indicators such as the SRI to rate the smartness of a building, and also invest in new ICT and software tools that help us to demonstrate the new or the renovated buildings will tackle with these EPBD standards. And last but not least, all these aspects need to be supported by the public and also private financing, and also be supported by technical assistance. So just to finalize, I hope that this will be followed by many other sessions and discussions in order to continue building knowledge regarding the building performance assessment methods and therefore accelerate the energy renovation. Thank you very much.
Yes, and thank you again to everybody. It was my pleasure to act as facilitator for this panel, and I hereby say that this is something that we already had in mind to have this session as a startup on this specific topic, which has an impact, as Pao already mentioned, on all the other aspects of the EPBD. And we are again lucky to have our Build Up portal colleagues to continue this webinar series on their portal. So stay in touch and you will hear from us soon on the next steps to take this further.